Good morning. Today we are going to discuss regular expressions. Till now, we have been discussing DFA, NFA without epsilon moves, and NFA with epsilon moves. And another representation of that means uh, we studied the equivalence of DFA and NFA, equivalence of NFA with epsilon moves and NFA without epsilon moves. Now we are going to discuss one more representation of regular set, which is called regular expressions, and there is a connection between all these, and that is pictorially represented as this is if you have NFA with epsilon transition, you can easily convert that to an NFA, simple NFA. That means NFA means it is a NFA without epsilon transition, and that can be converted to a DFA. And once you have a DFA, you can easily convert that to an RE. That means it is a regular expression. That means NFA with epsilon transition, NFA, DFA, and regular expression. RE means regular expression. That means NFA without with epsilon transition can be converted to an NFA, and once you have an NFA, you can easily convert that to a DFA, and once you have a DFA, can convert that to a regular expression, and a regular expression can be converted to an NFA with epsilon transition. That means here four different representation of the regular set or regular languages: NFA with epsilon transition, NFA, DFA, and regular expression. And among these, we discussed all these three. That means NFA with epsilon transition, NFA, DFA, and we know how the equivalence of NFA with epsilon transition and NFA without epsilon transition. Equivalence of NFA and DFA we discussed, and now we are going to discuss how DFA can be converted to a regular expression. So before that, discussing that, we are going to study what is a regular expression. And simply speaking, the primitive elements of a regular expression is phi is a regular expression denoting empty set. Phi is a regular expression denoting empty set. Epsilon is also a regular expression. I am going to write RE. Epsilon is also an RE, a regular expression, an RE. And if an A is an RE a regular expression provided A belongs to sigma. Suppose that sigma is the input alphabet of the string, then if this A is an element of this sigma, then simply A is a regular expression. Okay, that means suppose that if you have sigma is equal to say 0, 1, that means binary numbers. These three are, that means a string consisting of zeros and ones. Simply 0 is a regular expression, 1 is also a regular expression. Simply these are the regular expressions. Okay. Now this is a regular expression, and suppose that you have a regular expression. That means there are three operators we are going to discuss. Those are union, concatenation and clean closure. These are the operations that can be done on a regular expression. If you have two regular expressions R1 and R2, suppose that you have two regular expressions R1 and R2, then union of R1 and R2, union of R1 and R2 is represented by R1 plus R2. If you have two regular expressions R1 and R2, then the union of R1 and R2 is represented by R1 plus R2. And concatenation of R1 and R2 is R1 dot R2 or simply R1 R2. You can either represent it as R1 dot R2 or simply R1 R2. And clean closure of, that means here this concatenation and clean closure are two binary operations, whereas clean closure is a unary operation, and that is clean closure of R1. That means regular expression R1 is represented by R1 star. Okay, that is, if you have a regular expression, then phi is a regular expression denoting the empty set. Phi is a regular expression denoting the empty set. Epsilon is also an RE. A is an RE. And if you have, that means these are the primitive or these are the basic elements of a regular expression, and you can have very big regular expressions using union, concatenation, and clean closure. If we have two regular expressions R1 and R2, its union is represented by R1 plus R2. If we have two regular expression R1 and R2, concatenation is R1 dot R2, simply we represent as R1 R2, and clean closure is represented by R1 star. And we are going to discuss, we are going to have simple regular expression like this. For example, suppose that I am going to have, say, 0, 1 is a regular expression, or 1 or 0 is a regular expression, 0, 1 or 1, 1, that is also a regular expression. That means this will represent 0, 1. That means if you have such a regular expression, that means it is accepting 0, 1. This is accepting 1 or 0, either 1 or 0. This is, meaning of this is either 0, 1 or 1, 1. Either 0, 1 or 1, 1. And now we are going to discuss or how a regular expression can be converted to an NFA with epsilon transition, or simply how this is represented as an NFA with epsilon transition. Okay, so here phi is a regular expression, and that phi is represented by you have, this is the start state Q0, and suppose that QF is the final state, and empty set means there is no connection between this Q0 and QF. There is no connection between Q0 and QF. This is the representation of phi. That means no connection is there. That means it is an empty set. That means it is not accepted, and phi means the empty set. Okay. And epsilon. Now I am going to have epsilon. That means without epsilon means epsilon is a valid input, means without accepting anything that can be accepted. Okay. That means if this is the start state Q0, and suppose that it is also a final state. Here the start state itself is a final state, then this empty string can be accepted. But here in this case, this is null set. What is the difference between null set and empty set? Null means nothing is accepted. Empty set means that empty string can be accepted. Empty string can be accepted, whereas in the case of phi, no string is accepted. Here empty string can be accepted. That is the difference between phi and epsilon. And suppose that you have A, and if A is accepted, what will happen? Here you have a start state Q0 and a final state QF, and there is a connection between Q0 and QF labeled A. That means upon reaching Q0, this is a start state, it is accepting A. That means this phi is not accepting anything. This epsilon means it is accepting the empty string, and A means it is accepting a symbol or A. It is accepting A. And now if you have two regular expression, now we are going to have simple regular expression, and suppose that I am going to have a regular expression like say 1 or 0 1. This is a regular expression. What is the meaning of this? This is representing the language, either it is accepting 1 or 0 1 is accepted. That means in that language, suppose that the language is, or this is a regular expression R1 and that is 1 or 0 1. That means in this language L1, if this is the language L1 is having 1 comma 0 1 means in this language there are two strings that can be accepted. That is either 1 is accepted or 0 1 is accepted. Okay. Suppose that we are going to have 1 or 0 1 followed by 0 1. What will happen? What will happen? What is the string that can be accepted? That means 1 or 0 1 followed by 0 1. Then this will become what? 1 followed by 0 1 or 0 1 0 1. These are the strings that can be accepted by this regular expression, and in this way you can create whatever expression you want. That is 1 or 0 1. Now 0 1 0 or 1 1. What is the meaning of this? It is accepting either 0 1 0 or 1 1. That is union. That means either this or this. Or, that is, or is represented by plus. And now what is R1 R2? R1 R2 means R1 followed by R2. Suppose that R1 is say 0 0 1 and R2 is say 1 0, and the language accepted by R1 or the regular expression corresponding to this represents 0 0 1 and regular expression corresponding to this is representing 1 0, then what is R1 R2? R1 R2 is 0 0 1 1 0. That means this belongs to R1 and this belongs to R2. This one belongs to R1 and this belongs to R2. That means R1 followed by R2. R1 followed by R2. Now what is clean closure? 0 star means 0 or more occurrence of 0. That means it is representing 0 occurrence of 0 means the language, suppose that R1 is equal to R0 star. What will happen? This star represents 0 or more occurrence of this 0. That means 0 occurrence of 0 is epsilon, 1 occurrence of 0 is 0, 2 occurrences of 0 is 0 0, then 0 0 0, etc. That means this is having infinite number of elements in it. Why? 0 star means 0 or more occurrence of 0. Suppose that I am going to have 0 1 star. What is the meaning of 0 1 star? That means that 0 1 is repeating 0 or more times. For example, here if this is occurring 0 times, what will happen? This is epsilon. This is repeating only one time. In that case, this will be 0 1. If it is occurring 2 times, 0 1 0 1 0 1. If it is occurring 3 times, 0 1 0 1 0 1 and like this. Okay, that means this is 0 1 star, and that is all about these three operations. That means union of R1 and R1 and R2 means either R1 or R2 will occur. R1 R2 means concatenation means one followed by the other, R1 followed by R2, and linear closure means that is repeating any number of times, 0 or more occurrence of that. And when you are talking about linear closure, there is a positive closure also. Positive closure is represented by, positive closure is R1 is, instead of star we are going to have plus. Here the difference between linear closure and positive closure is, for linear closure 0 or more occurrence of R1, but in the case of positive closure 1 or more occurrence of R1. For example, if you are writing 0 plus, the meaning is the language accepted is L is equal to 0 plus means 0 or more, 1 or more occurrence of 0. That means empty string is not accepted. 0, 0, 0, 0, 0, 0, etc. That means the epsilon case, that means 0, 0 occurrence of 0. That has to be avoided. Okay, that is not in this. That means 1 or more occurrence of plus. So these are the basic operations on regular expressions, and can have union, intersection, negation, homomorphism, etc., etc. A number of operations that can be done on regular expressions, but we are focusing on these three. And now we are going to discuss how, if a regular expression is given, how that can be converted to an NFA with epsilon transitions. For example, I am going to have some examples. For example, suppose that you have an integer. Suppose that in C program, what is a valid integer? Valid integer. Okay, an integer is having. Suppose that I am going to have, say, a variable called digit. Digit is equal to 0 or 1 or 2 or 3 or etc. up to 9. Okay, that means a digit is represented as either 0, 1, 2, 3 etc. up to 10. That means 10 different digits are there. Either one of them can be chosen as a digit. Now I am going to have another one, digit minus 0. That means I am going to exclude 0 from this, and I am going to have 1 or 2 or etc. up to 9. That means this digit minus 0 is not having 0. Now I am going to create a valid integer. I am going to have an expression like digit minus 0. That means it should start with either 1, 2, 3 or etc. up to 9. It should not start with an integer value does not start with 0. It should be either 1, 2 or up to 9. That means any digit other than 0. That means that is a starting point. That means the first digit should be either 1, 2, 3 etc. up to 9, followed by digit. That means now we can include zeros also. Star. That means this is the first digit is either 1, 2, 3 etc. up to 9, and subsequent digits are 0 to 9. That means there is no limit. That means 0 or more occurrence of this. For example, I am going to have 1 0. That means this is coming from digit 0 and this is coming from digit. Then the digit is 0 or 1 or 2 or 3 or etc. up to 9. Okay. Now suppose that we are going to, these are integers, and now decimal a simple decimal number also I am going to take. So decimal number. Okay. Now a decimal number is having a dot, and on both sides of the dots there should at least be one digit. Okay. That is, here anyway you are having, before that decimal place there should be an integer. There should be an integer. So I am going to write digit minus 0, digit star dot. Now you have a dot. And if this dot has to occur, then on the right side there should at least be a single digit. Now I am going to have digit followed by digit star. Digit followed by digit star means if a decimal place is there and to the right there should at least be one digit, and that is that digit followed by 0 or more occurrence of digit, or you can simply write here digit plus. That means one or more occurrence of digit. Okay, you can have 10.0 or 11.53. These are all coming from this, and this is a way of, this is an example of a regular expression. Now, suppose that you have a regular expression, a simple regular expression is represented by, suppose that I am going to have a regular expression, say R1. Suppose that you have a regular expression R1, simply that is represented by, here this is, here we have a start state and here we have a final state, and this is R1. R1 is represented by a simply a start state, that is represented by this, and you have a final state. Now suppose that we have another regular expression, say R2, and that can also be represented like this. In that case also you have a start state and having a final state. Suppose that you have two regular expressions R1 and R2, then R1 is represented by the first diagram and R2 is represented by the second diagram. That means you have a transition diagram, and in this box there are a number of states which will take you from your start state to your final state. And here in this case also you have a number of states, and I have closed in a closed box. Anyway, you have a start state and a final state for R1, and you have a start state and final state for R2. Suppose that if you are taking the union of this means either one of these should occur. That means here if you are going to have R is equal to R1 or R2, you are going to take the union of R1 and R2. In that case, you are going to have a new start state. This is the new start state, and a new final state also you are going to have, and the new final state is QF, and your new start state is say Q0. Now this is the new start state. Now you are going to connect these two using an epsilon transition. That means from your start state to the start state of R1, you are going to have an epsilon transition. Here also you are going to have another epsilon transition, epsilon. Okay. Now from these two final states, you are going to have epsilon transitions to the final state. That means here suppose that R1 is represented by an NFA with epsilon transition. M1 is equal to, say, I am going to have Q sigma delta. Here the start state is say Q1 and the final state is Q1F. That means This is the start state Q1 and this is Q1F. And suppose that M2 is equal to, here the set of states are Q1, sigma 1, delta Q1 and Q1F. Suppose that M2 is equal to Q2, sigma 2, delta 2. Here delta 1, delta 2. This is Q2 and suppose that Q2F. That means entirely different. These two are entirely different. That means here we have a regular expression or you have an NF with epsilon transition which is accepting R1 and you have another NF with epsilon transition which is accepting R2. When you are taking the union of these two, then the first NF with epsilon transition is represented by M1, that is Q1, sigma 1, delta 1, Q1 and Q1F. That means Q1 is the start state and Q1F is the final state of R1, and here Q2 and Q2 are the final start and final states of R2. Then what is M1 plus M2? That means you are taking the union of these two. Here the set of states are Q1 union, Q2 union. That means all the states of this first NFA, all the states of the second NFA, plus you have added two states. That means one start state and one final state. That means union. Here we are going to have two more states, Q0 and QF. So for the union of M1 and M2, the new set of states are Q1, Q2, Q0, QF. That means Q1 union, Q2 union, Q0 and QF. And the input alphabet is sigma 1 union, sigma 2. That means all the input symbols of this one, or all the inputs of the input symbols of the first NFA, all the input symbols of the second NFA union. You have added epsilon also should be included, epsilon. Okay. Then delta 1, what is the transition function delta 1 and delta 2? That means delta 1 union delta 2. Apart from that, you have another transition. That means delta of Q0 on epsilon is Q1, this is Q2, Q1, Q2, and delta of Q1 F1 epsilon is QF, and delta of Q2F on epsilon is QF. Though that too should also be included. That means delta function is also there. That means Q sigma delta. The new start state is Q0 and the new final state is QF. So this is the union of those two. That means if you are converting, if you have two regular expression and if you are taking the union of those two, then the equivalent NFA is looking like this. I will show you with an example. See, suppose that you have say 1 or 0. Suppose that a simple case is this 1 or 0. That means simply for 1 you are going to have a regular expression which is represented by, this is the start state and this is the final state and this is accepting 1, and you have another regular expression which is accepting 0. Okay, 0 and 1, and now you are going to have, this is 0 and this is 1, and if you are concatenating 1 or 0, that means you are going to concatenate this. You are going to have a new start state here and you are going to have a new final state here, and Here, from here and here, you're going to have an epsilon transition. You're going to have an epsilon transition. Here you're going to have another epsilon transition, and here you're going to have another epsilon transition, and make these non-final states. Make these non-final states. Now, this is the single start state, and this is the single final state. Okay. Now, this is 1 or 0. 1 or 0. Now, another example I will show you. Suppose that 1 1 or 0 1. 1 1 or 0 1. So, what is the regular expression for 1 1? That means it is accepting, this is the start state, and it is accepting 1 and 1. That is accepting 1 1, and this is the final state. And another one which is 0 1, that means this is 0 and this is 1. So that is the start. So this R1 is accepting 1 1, and this is accepting 0 1. Now we are going to have 1 1 or 0 1. What will happen? You are going to have a new start state Q0 and a new final state QF. Okay. Now from here you are going to have an epsilon transition. Here also you are going to have an epsilon transition, and make these two non-final. Make these two non-final, and from here you have an epsilon transition. Here also you are going to have an epsilon transition. Now that's all about union. We are going to discuss concatenation operation. Concatenation. Suppose that you have two regular expressions R1 and R2. R1 and R2. And the previous example, this is R1. R1 is having a start state and a final state, and suppose that we have R2 here. This is R2, and this is also having a start state and a final state. Now here this is the start state and this is the start state for here, and this is represented by M1 and this is M2. Now M1 is having Q1 sigma 1 delta 1 Q1 and Q1F, and M2 is equal to Q2, this is Q1, Q2 sigma 2 delta 2 Q2 and Q2F. Okay, that means these are the set of states for M1. Sigma 1 is the input alphabet for this, delta 1 is a transition function corresponding to this, Q1 is the start state of this, and Q1 is the final state of this. That means now we are going to have M1 dot M2. That means, or we are going to have the regular expression of two concatenated R1 R2. R1 R2 means what you are going to do is make this a non-final state, and here you are going to have a transition from here to here and epsilon. That means this is the only thing you have to discuss. You have to consider. That means now no more states you have added. Simply make this the final state of the first one. Final state of the first regular expression. Make it a non-final state, and from that state to the start state of the second one, you have a new transition which is an epsilon transition. That's all. Okay. For example, and if you have M1, M2, that means here we are going to have again Q1 union Q2. That means Q1 union Q2. That means any more No more additional states. Here Q1 union Q2, sigma 1 union sigma 2 union epsilon. That means you have added an epsilon transition. Then delta 1 union delta 2 union delta. That means delta of the final set of this one epsilon is this. Okay, delta. Then new start state is Q1. That means start state of the first one and the final state. Suppose that this is Q2F and this is Q1F and the new final state is final state of the second one. Okay, that is Q sigma delta Q0F. And I will show you how you can do this with the help of an example. Suppose that we're going to have 0, 1. So simply this is 0 and this is 1. I'm going to have the regular expression for 0 is this one and this is the final state on 0. That means this is the start state and this is the final state. On 0 it reaches or it starts from the start state reaches the final state on accepting 0. And another regular expression which is accepting 1. Okay. Now I am going to, that means you have 0 and 1. Now 0 and 1 and now after this you are concatenating this to 0, 1. What you can do is make this a non-final state. Make this a non-final state. Here you are going to have an epsilon transition and that's done. And that's done. And this is 0, 1. Theoretically. Can have say 0, 1 without using this epsilon can have, but when you are concatenating two regular expression, the equivalent NFA with epsilon transition can be pictorially represented like this. Okay. And now what about Kleene closure? Kleene closure is, suppose that you are having 0. The expression for simple 0 is like this. That means from the start state on accepting 0 it reaches a final state. Okay. Now I am going to have 0 star. 0 star means 0 or more occurrence of this. 0 or more occurrence of 0. That means if you are converting this regular or this NFA with epsilon transition to its equivalent 0 star. Here simply is 0. That means this is the start state and this is the final state and this is accepting simple 0. Now I am going to have 0 star. That means 0 or more occurrence of zeros. What I am going to do is you are going to have from the final state to the start state you are going to have an epsilon transition. Okay. But if you look at this, this is accepting at least 1 0. That means at least 1 0. That means if it is 0 plus this is okay. That means from the start state if you want to reach the final state you need at least a single 0. You need at least a single 0. But 0 star means empty string also should be accepted. Epsilon 0 0 0 0 0 0. That is represented by this. That means epsilon also have to be included. But here in this case, if you have an epsilon transition here, once you reach, that means from the start state to reach the final state, you need at least a single 0. After that, you can repeat. No problem. But in this case, there should at least be a single 0. But that is not the case. Some empty string also should be accepted. For that, what you are going to do is, you are going to have a new start state here and here you are going to have a new final state here. And from here you are going to have an epsilon transition from the final state of the original to the new final state of new final state you have created, there also an epsilon transition, and make this the start state, and you are going to have an epsilon transition from the new start state to new final state. That means now from here you can straight away reach here without reading any input. That means epsilon also should be included. Epsilon is included. But once you reaches here, that means one single zero you can reach here and final state. If you have two zeros, what will happen? From here it reaches here. After that a single zero, coming back two zeros, coming back three zeros. That means if after two zeros, if you want to terminate, then from here you can switch to the final state. Okay, this is the way. This is the way you can achieve clean closure. For example, another example I will show you. That means 0 1 star. Then what is 0 1? 0 1 is from the start state. This is 0 and this is 1. Okay. If you want to repeat that, this is the thing, and from here you are going to have an epsilon transition. Here also you have an epsilon transition. That means 0 1 star. Okay. Using these techniques can have any regular expression, and once you have the regular expression you can easily convert that to an NFA with epsilon transition. And with one more example, I will conclude this session. I am going to conclude the session. For example, I am going to have say 1 0 or 0 1 star 0 1 0 1 or 1 0 star. I am going to have now initially you have to split this into 3. That means 1 0 or 0 1 star followed by 0 1 followed by this. That means suppose that this is R1, this is R2 and this is R3. Now I am going to construct 1 0 or 0 1 star. So if you are looking at this, here it is 1 0, here it is 0 1, and that is the concatenation of 2 and then taking the clean closure. Okay, that I am going to draw. That means 1 0 or 0 1. Simply 1 0. This is the start state. This is 1 1 0. From the primitives, if you do this, then it will look like this. Here you have epsilon and this is 1. Okay, that means 1 0. This is not 1. This is 0. That means initially you have 1 and this is the expression for 0. When you are concatenating this 1 and 0, you get 1 followed by this epsilon transition followed by 0. Now, and I am going to do this like this 1 0. This is the final state. Now 0 1. That is 0 1 and that is the final state. Now 1 0 or 0 1. That means you are taking the union of these two. Then you are going to have a new start state here. Epsilon. Here also you have epsilon and this is the final state. Here also an epsilon. Here you have an epsilon. And make this non-final. Make this non-final. Now what is this? That is 1 0 or 0 1. This is the start state. 1 0 or 0 1. That means after reaching here, if you want to reach here, either 1 0 or 0 1 should occur. Either 1 0 or 0 1 should occur. Now, you are going to have the clean cluster of this. That means 0 or more occurrence of this. 0 or more occurrence of this. Then what you are going to do is, this is the thing you have to repeat. Okay. For that, what you're going to do is, if you want to have clean closure, initially you have this is the new start state, and here you are going to have a new final state. Okay. Now from this start state to the original start state, you have an epsilon transition. From the earlier final state to the new final state, you have another epsilon transition. Now, if this has to be from this place to this place or from this state to this state, that is the original. If you want a repetition, then you should have an epsilon transition here. That means that is repeating again and again. Okay. And if empty string also has to be included, then you should have an epsilon transition like this. That is, this is 1 0 or 0 1 star. Okay, likewise here you can have 0 1 or 1 0 star and can have 0 1 here. That means, now suppose that this is the regular expression for, I will show you. That means the expression for 0 1 is 0 1, and that is the final state. And 0 1 or 1 0 star, 0 1 or 1, and that you have to complete yourself up to this. That means 1 0 or 0 1 star, 1 0 1. What will happen here? From here you are going to have an epsilon transition to this node. Make this non-final. Okay, in this way you can have 1 0 or 0 1 star or 0 1. Now do this as an exercise, then concatenate that with this. And this is the way you can create regular expressions